So P2, exponents and radicals. We're going to start by looking at some properties of exponents. When we're multiplying two terms, so looking at number one, if we're multiplying two terms that have the same base, we can add the exponents together. So in the example, it says 3 to the second power times 3 to the fourth power. We can add the exponents, so it would be 3 to the sixth power, because 2 plus 4 would be 6. So when you're multiplying, you add the exponents. If we're dividing, we subtract the exponents. So a to the power of m over a to the power of m would be a to the power of m minus n. We subtract. For 3, if we have a negative exponent, we move it to the denominator and it turns positive. So if I had y to the power of negative 4, we would move the y to the fourth power to the bottom and the exponent turns positive. Anything to the power of 0 would be 1. So you could have a million to the power of 0. It would just be 1. If we have two terms that are being multiplied to an exponent, we distribute that exponent to both terms. Now this is not the same if we were adding these two together. If we're adding them, you'd have to FOIL. If you're multiplying inside the parentheses, just distribute the exponent. If we have a power raised to a power, we multiply. So if I had, let's say, x to the power of 2 to the power of 5. If you have a power raised to a power, you multiply these two together. So this would be x to what power? The 10th power. If you have a fraction raised to a power, you can distribute the exponent to the numerator and the denominator. And then in absolute value, you can take out the exponent of the absolute value. So we're going to be using these properties in our next few examples. So looking at example 3a. So we're multiplying. We want to make sure we combine our like terms together. So I'm going to start by multiplying the coefficients. Negative 3 and 4. Awesome, negative 12. Now we can just multiply because we don't have exponents on the parentheses. These are just solo terms that we have in here. So negative 3 times 4 gave us negative 12. Now let's multiply the a's together. What is a times a? A squared, awesome. The exponent on our a's would be 1. When we multiply, we add the exponent, so that's how we get a to the second power, a squared. Now let's do the same thing for the b's. We have b to the fourth power times b to the negative third power. If we add the exponents, what do we get? B to what power? B to the power of 1. Now do I write b to the first power? No, so it would just be b. So this would be our answer. So just take the like terms one at a time and multiply them together. Since we are multiplying, we add the exponents. 4 plus negative 3 is what gave us 1. Any questions here? All right, let's go below to b. So we have multiple terms inside of our parentheses. They're being multiplied, so we can distribute the exponent to everything inside the parentheses. So we have 2 to the third power, x to the third power, and y to the second power to the third power. What is 2 to the third power? 2 times 2 times 2. 8. Awesome. Then we have x to the third power, and then y squared to the third power. What do we do when we have a power raised to a power? Multiply. We multiply these two. So this would be y to what power? The sixth power. Any questions here? Let's look at C. Now I see that I have an exponent of 0. What's anything to the power of 0? 1. But we need to be careful here. What has the power of 0? The parentheses. So all of the parentheses turns into 1. And what's 3a times 1? 3a. Perfect. So our answer would be 3a. So it's just what the power of 0 is touching, which are the parentheses. So the parentheses changes to be 1. And let's look at D. So here I've got a lot going on the inside to the second power. What can we do with that exponent, the second power? We can distribute. Be careful. Make sure you distribute it to everything. It gets distributed to the 5, to the x, and to the y. Some people forget to multiply it to the, or distribute it to the coefficient, the number. Some people forget to do the denominator. So just make sure you distribute it to everything. So we have 5 to the second power, x cubed to the second power, over y to the second power. Now let's simplify. What's 5 to the second power? 25. What do we do when we have a power raised to a power? Multiply. So this would be x to what power? X to the 6th power. And then y to the second power, over y to the second power. Next page, we're going to talk about radicals. So with radicals, we got to remember a few things. The number out front is our index. So if I had, let's say, the cubed root of x, the cubed is the index. If I don't have an index written, so let's just say I had the square root of x, what's implied that the number out front is? Not 1. 2. It's implied that it's a 2. So if there's no number written, it's implied that our index is 2. Now, if we have an even index, let's say if it says it here. If we have an even index, we can't take the square root of a negative. So let's say we had the 4th root of negative x. This is not real. Can't do it. But if I had an odd index, let's say I had the cubed root of negative x, we can do this. It would be a negative number. So this we can do. So an even index, we cannot take an even index of a negative number. An odd index is okay. That's pretty much what this table is saying. So like here it gives us the example. The cubed root of negative 8 would be negative 2. But if we had the square root of negative 4, this is not a real number. It would be imaginary. So let's look at some properties of radicals on the next page. So if we had an exponent underneath the radical, we can move it to the outside. So if I had the square root of 2 to the 3rd power, this is the same thing as saying the square root of 2 to the 3rd power. So if it's on the inside, you could put it on the outside. If it's on the outside, you could put it on the inside. Whatever you want to do to help you solve, to simplify. If we are multiplying two terms that have the same index, we can multiply them together. We can combine them under one square root. So if I had, here in the example is a good one, the square root of 5 times the square root of 7, we can turn that into the square root of 5 times 7, or the square root of 35. So we can combine them together if they have the same index. Same thing if we're dividing. If we had the square root of 27 over the square root, here it's the 4th root, but the 4th root of 27 over the 4th root of 9, you can combine those together, and it'd be the 4th root of 27 over 9. The rest of them I don't think that we'll see. If we have the same index, and exponent, they cancel out. And we would just be left with whatever's under the radical. So if I had the cubed root of, let's say, 10 to the third power, the cubed root and the third power would cancel, and our answer would just be 10. So if you have the same index and exponent, they cancel out. You'll see this often. Any questions here? Let's do some examples. So example A, we have the square root of 8 times the square root of 2. We can combine these together, and we could make this the square root of 8 times 2, which would be what? 16. Then we can break it down, because we can't leave it as the square root of 16. Some of us may know what the square root of 16 is right off the top of our head. If we don't, let's break it down. Let's simplify it. What are 2 factors of 16? 4 and 4. We could simplify this some more. What are 2 factors of 4? 2 and 2. It's a square root, so my index is 2, which means that I circle 2 of a kind. So if I have 2 pairs of 2, what comes to the outside? How many 2s? How many circles do I have? 2. So 2 2s would come to the outside. And what's 2 times 2? 4. Now again, some of us may just see square root of 16 and think right off the top of our head, oh, that's 4. It's not always going to be a perfect square, so you may have to break it down. Do your factorization tree. Break it down to all the factors. Since our index was 2, we circle 2 of a kind. Now another way that we could have done this, let's say this was really big numbers and we couldn't multiply them together. You can leave them separate. I could leave it as the square root of 8 times 2 and then break it down from here. What are 2 factors of 8? 4 and 2. And then I've got 2 there. I could break this down. 2 factors of 4. 2 and 2. I'm just going to drop these so we can line it up. And we get the same thing. I've got 2 pairs of 2s, which would be 2 times 2, which is 4. So you don't have to multiply it together. If this was really big numbers, you maybe wouldn't want to multiply it together, or just break it down from what you have. Any questions there? Let's look at B. We have the cubed root of 5 cubed. What would this be? 5. Awesome. The cubed root and the cube cancel because we have the same index and exponent. So this would just be 5. What about for C? Same thing. We've got the same index and exponent, so they cancel. So our answer would just be x. Now remember, we said that we could write the exponent either on the inside or the outside. So this would be the same thing as the cubed root of x to the third power. Same thing. Which again would just be x. So just 2 different ways of seeing it, but they mean the same thing. What about for D? Same thing. What would our answer be? Y. Perfect. All right, so we're simplifying radicals some more here. So here we have the cubed root of 24. Cubed root means that we need 3 of a kind. So let's break this down into all of the factors. So what are 2 factors of 24? 4 and 6. That works. If you said 2 and 12, that would also work. There's many different answers to begin with. You just don't want 1 and 24. You've got to come up with something other than 1 in itself. What are 2 factors of 4? 2 and 2. And 2 factors of 6? 2 and 3. So if our index is 3, that means we need 3 of a kind in order to come out from the radical. Do I have 3 of a kind? Yeah, I've got 3 2s. So what's going to come to the outside? A 2. What stays on the inside? The 3. 3 didn't have a pair, so it has to stay on the inside. Now our radical has to have the same index in our answer that it's in the question. So we would have the cubed root of 3. So since we had the cubed root in the question, we got to make sure that it's the same index in the answer too. So this would be our answer. 2 times the cubed root of 3. So what's our index here? 4. So how many of a kind am I going to need? 4 of a kind. So let's break this down. What are 2 factors of 48? 6 and 8? You could come up with other factors than 6 and 8. That works. But you just need 2. So as long as you got 6 and 8, you're good. From here, we can break down the 6 and we can break down the 8. If you said 2 and 24, that would also work. You'll end up with the same numbers at the end. What are 2 factors of 6? 2 and 3. What are 2 factors of 8? 4 and 2. Can we break this down any more? What? 4 gets broken down into what? 2 and 2. Now, do I have 4 of a kind? 4 of what? 2. Got 4 2s. 1, 2, 3, 4. So I'm going to circle these. Sometimes it helps write it all out in a line. 2, 3, 2. So you can kind of see it a little bit better. That way nothing gets left behind. So I've got 4 2s. So since I've got a group of 2s, they can come to the outside. What has to stay on the inside? What did not get circled? The 3. What's my index in my answer have to be? 4. So I have the 4th root of 3. 3 didn't have a pair, so it had to stay on the inside. And then your index has to be the same as whatever the index in the question was. So how many A's do we have?
4.
1, 2, 3, 4. How many of a kind do we need?
3.
So I'm going to circle 3 of them. What comes to the outside? How many A's? Just 1 A, because I only have 1 circle. How many A's stay on the inside? 1. So 2A times the cubed root of 3A would be our answer. Let's do E on the next page. What are we thinking here? It cancels out, so what would our answer be? 5x, perfect. Another way that we can think about it, if we don't see that it cancels right off the top of our heads, we could have the 4th root of 5x to the 4th power. We've got 4 of them, so 5x times 5x times 5x times 5x. Then you could circle your 4 of a kind, which would come out as 5x, so same thing. All right, next page. Combining radicals. When we are adding or subtracting, you can only combine the radicals if you have the same radical. So I can only add square root 2 plus square root 2. We would just add the numbers out front. But I can't add square root 3 plus square root 2. I'll write that down. So we could add square root 2 plus square root 2. This would be 2 square root 2. Which we'll do some examples. But I cannot add square root 3 plus square root 2. Can't combine. So they have to have the same number underneath the radical in order to add them. Let's look at A. We don't have the same radical, so we can't combine them right off the bat, but let's simplify and see if we can combine them. So let's break down each radical. What are 2 factors of 48? 8 and 6. Or you could say 4 and 12. Whatever 2 numbers you come up with, it'll break down to be the same thing. What are 2 factors of 8? 4 and 2. And 2 factors of 6? 2 and 3. And then 4 can break down into 2 and 2. How many of a kind am I circling here? 2. We don't have an index written, so it's implied that our index is 2. So I've got 2 of a kind, 2 of a kind, and then 3 doesn't have a pair. What's going to come to the outside?
2a squared.
So we already have a 2 on the outside, so I'll write that 2 here. From the inside, how many 2's are going to come out? 2. So then we have a 2 times 2. And then what stays on the inside? 3. So the square root of 3. So then here, let's combine. Let's simplify a little bit more. What's 2 times 2 times 2? 8. So this would be 8 square root 3. Now let's do the same thing with the second one here. Let's break it down. What are 2 factors of 27? 9 and 3. And 2 factors of 9? 3 and 3. How many of a kind am I circling here? 2 of a kind. So we've got 2 3's. So I had a negative 3 on the outside. I'll leave that as a minus 3. What else is going to come to the outside? A 3. Since I had a circle of 3's, that comes to the outside. What stays on the inside? A 3. So square root 3. And then when I pull something out, if I already have a number outside, we just multiply them together. So what's negative 3 times 3? Negative 9. So negative 9 square root 3. Can I now subtract these together? Yeah, we have the same square root. In order to subtract them, or when we subtract them, we just subtract the numbers out front. So we have 8 minus 9. What's 8 minus 9? Negative 1. So negative 1 square root 3. Do I need to put the 1 there? No. It's just like saying 1x. We wouldn't put 1 in front of the x. It's just x. So we don't put the 1. So this would just be negative square root 3. So we're going to do the same thing for b. I can't subtract these right off the bat because they've got different numbers, different terms on the inside. Let's see if we can break it down. How many of a kind do we need here? 3. Our index is 3, so we need 3 of a kind. What are 2 factors of 16? 4 and 4. What are 2 factors of 4? 2 and 2. So I've got 2, 2, 2, 2. We said we need 3 of a kind. So what's going to come to the outside? A 2, because I've got one circle of 2's. What stays on the inside? A 2. So since my index was 3, I have to make sure that I write that in my answer. I've got the cubed root of 2. And then let's look at the x. How many x's do I have? 1. Do I have enough to come to the outside? No, so that stays on the inside. Let's do the same thing with the second part. So let's break down 54. What are 2 factors of 54? 6 and 9. What are 2 factors of 6? 3 and 2. And 2 factors of 9? 3 and 3. How many of a kind do I need here? I need 3. Do I have 3? Yes, I've got 3 3's. So what's going to come to the outside? A 3. What stays on the inside?
2.
The 2. So I've got the cubed root of 2 still left on the inside. Let's do the same thing with the x's. Everybody with me so far? All right, let's break down the x's. How many x's do we have? We've got 4. How many are we going to circle? 3. So how many come to the outside? 1x. How many stays on the inside? 1x. All right, now we have the same things under the square root, but this one's a little tricky. Can we add these together? Why not? They don't have the same amount of x's. If this didn't even have the square root, could I add 2 minus 3x? Can I add these or subtract them together? No, they're not like terms. So we can't subtract. So this would be our answer. So even though they had the same square roots, same cubed roots here, can't combine it because that x that's on the outside there makes it not like terms. All right, so next we're going to talk about rationalizing denominators and numerators. Rationalizing is when we have a square root and we want to get rid of it. Typically, we don't like to leave square roots in our denominator, so we want to rationalize to get rid of it from the denominator. So looking at example 12, to rationalize the denominator, we want to get rid of the square root from the denominator. There's a couple different ways that we can do this. The easiest, I would say, is we want to see what our square root is, and we're going to multiply whatever the square root is to the top and the bottom. So I'm going to multiply the square root of 3 to the top and the bottom. Now on top, we can't combine these together because 5 doesn't have a square root, so I'm just going to leave it as 5 square root 3. On the bottom, I can combine the square root 3's together. What's square root 3 times square root 3? It would be 3. It is the square root of 9. What's the square root of 9? 3. And then I still have that 2 on the outside, so what's 2 times 3? 6. So our answer would be 5 square root 3 over 6. Any questions here? Perfect. The other way that we could do this, if we had 5 over 2 square root 3, so same question, you can multiply the top and the bottom by 2 square root 3. I'll just show you that this is going to be more work. But 5 times 2 is 10 square root 3 on the top. On the bottom, we have 2 times 2, which is 4. And what's square root 3 times square root 3? It'd be square root 9, which is 3. And 4 times 3 is 12. Now here we have 10 square root 3 over 12. This doesn't look the same as the first answer that I got, because I need to simplify. So we can simplify the whole numbers here. What goes into both 10 and 12? 2. So this would be 5 square root 3 over 6. And we divide them by 2. So same thing, just a couple more steps. Either way works. Just don't forget to simplify it. If you do the second way, don't forget to simplify it at the end.